And just a reminder to everyone, we are both recording and transcribing. Since we've already got a few folks, I'm going to go ahead and get my screen up. We are, of course, here to hear all of Kristyna Ferris's wonderful additional information about how we can perform data quality checks using Python and SQL. And I promise I will give the microphone back to her after some announcements. But to get us started, and while people are still joining, we always try to capture a little bit of a sense of who's hiring and who's looking. So while people are joining the chat, if you have opportunities that you know of in the area or just in general, and you want to share it with the group, please go ahead and pop those in the chat. And if you're looking for new opportunities, normally when we do this in person, we ask everybody to share that as well. So feel free to pop that in the chat too. This is a great opportunity for people to be able to connect the dots between new opportunities and people looking for those possibilities. Okay, and we are officially at 6 p.m., so I'm going to go ahead and get started. Welcome to Power BI DC. For those of you who are new, we are a community-based meetup made up of volunteers, including wonderful folks like Stevie, who's helping us moderate today. But the two co-organizers are me. I'm on the right hand there. That's Lenore Flower. I run Data Plumber LLC. I make stuff. I throw ducks at people during conferences. I'll explain that later if anyone's curious. And right now, my big thing is working towards getting the Beautiful Nerds podcast up and running. My co-conspirator, Leslie, is out putting out fires at work, but she is a fantastic expert in the data and AI field who would love to go climbing with you and talk ad nauseum about all things data viz. We have our next in-person meetup, and that will be in-person only with our buddy Dom Romito. From the audience to the speaker on the stage, that's going to be coming up on Thursday, May 22nd from 5:30 to 7:30 p.m. Eastern Standard Time. And it will be one of the last in-person meetups that we'll be having at the Arlington Tech Exchange. This one's particularly exciting because it's going to kick off an effort to help us get a few fledgling speakers for Power BI Days, which is happening in June. So if you are in the DC area and you would like to take the plunge and do your first speaking event, but you've always been a bit nervous about it or you're not quite sure where to start, we're going to be providing support between Dom's session in May through Power BI Days to help make sure that everybody has what they need to be able to have their first speaking event successfully. So if you think this might be for you, the next steps are to attend next month's meetup with Dom, then to sign up for a lightning talk at Power BI Days DC. We're going to have a special round of lightning talk signups starting that night for the meetup. We'll be using a group of people who have already said yes, very enthusiastically, as speaker mentors. These are folks that are experienced and have been engaged with speaker opportunities for at least a couple of years now. They will help you one-on-one refine the topic that you want to talk about and give you some presentation prep support so that you're ready to do your first lightning talk. We'll also be setting up some time for us to do some practice and support so that the group of folks that are also doing their first time speaking are able to support you and cheerlead each other. And then the goal is for the folks that sign up for this to present their first session ever at Power BI Days DC. Lightning talks are 5 to 15 minutes max, so it's quick. We are keeping it a little bit longer at 15 minutes because it's really hard to write a 5-minute talk well, and we want to make some room for that. But the goal is for this to be something that'll be done in a very supportive way with a lot of opportunities to get feedback and positive energy in advance. So think about that now. And if you're in the DC area, we'd absolutely love to see you for the May 22nd event and have maybe 4 to 6 of you join us for Power BI Days DC as newbie speakers. And just in case you're wondering if it's worthwhile to be a first-time speaker, I do want to point out that 25% of Power BI DataViz finalists are first-time speakers at Power BI Days. So if anybody followed the Power BI DataViz World Championships, you may be aware that Lakshmi, who's the one with the giant arrow over her head, was one of the 4 who were selected and did an exceptional job competing. She did her first speaking engagement at Power BI Days DC last June, and we are very, very proud of her and continue to cheer her on as much as we can. So we'd love to take that energy and carry it forward to anyone that wants to take the plunge. Obviously, I'm talking about Power BI Days a lot here, so I want to encourage anyone that's in the DC area to save the date. From June 12th to 13th, we're going to be having Power BI Days, and we have a really exciting lineup of events. Power BI Days is entirely free, which means that I will be lovingly harassing people to help me cover things like food costs over the next couple of months. But we'll have Alex Powers, who, of course, is It's Not About the Cell, and who is regularly on the Fabric subreddit as well as LinkedIn as our keynote. We'll also be having a Power Query escape room. This is a project John Kursky came up with, and we're really excited to launch. As part of that newbie speaker support roundup, lightning talks will be happening over a happy hour on the first day of Power BI Days DC. And we're also planning tentatively to have a local DC DataViz competition with some support from Shannon Lindsay, who has been figuring out how to make a small scale version of this DataViz competition that she championed for FabCon available for us locally, and some help from Lakshmi as well. But for any of that to happen in a completely free conference, we could really use some volunteers. So if you're in the DC area, I would love help in any of the areas below to help us make it happen. You can sign up to volunteer, and I will put a link in the chat when I'm done yammering at you in a few minutes. You can submit a conference session or several. Current deadline for that is April 30th. If that feels too daunting and you don't want to go the newbie speaker route, you can also just encourage speakers you love to submit a session. I have been lovingly harassing other speakers to get them to join as well. Long shots that you love are worth a message on LinkedIn. We'd love to have anyone who is as excited about Power BI as we are join Power BI Days. And if you have a company, a university, an organization that might enjoy having a table at Power BI Days DC, might enjoy simply sponsoring it for the name recognition or for, good vibes, we are looking for sponsors to help cover food, coffee, and things like that. It's a zero budget conference and our love is cheap. So it really is just the cost of the food to help make that happen. So those are 4 things you can do. I'm also going to include the save the date link, which will allow you to sign up early. We do this so that people aren't signing up until closer to the event because it's so easy to forget. But you can reserve your spot early and make sure that you have that time scheduled well in advance so you are able to attend. That's our way of sort of balancing the two. The only other thing I will say is when we do open up sign up, please make sure that you actually show up. We have split it so that you'll be able to sign up for either or both days. And we just want to make sure essentially that we're making sure that everyone who wants to attend is able to do so. Last year we sold out and we extended the wait list 2 or 3 times. And we were still forced to kind of tell some folks no at the door. So please help us make sure everyone can attend. And if you do sign up, make a point of showing up. If you have to say no closer to the date, make sure you tell us at least 48 hours in advance so we can get those folks on the wait list, onto the list to attend. Okay, I'm almost done, I promise. Some of you may have heard about the Microsoft AI Skills Fest. If you are working on getting prepared for the DP700, which is the Fabric Data Engineer, you can get involved with the Microsoft AI Skills Fest and sign up for the various exercises as part of that. If you complete one of the challenges, you'll be able to be in the running to get a free voucher for various certifications, including the DP700. And I recently heard from our friends over at Microsoft that they're going to be having a Get Certified, Become a Fabric Data Engineer series starting on April 30th that will be live and help you to prepare for the exam. So I believe that's going to be happening at 8 a.m. Eastern, and I'll include the link in the chat shortly as well. Finally, our June event right after Power BI Days will be online, and it will be Intro to Measure Killer 2.0. If you're not familiar with Measure Killer, it is my favorite third-party tool. I have a hat now that I got from FabCon, and it is a really exciting way to be able to quickly clean up various reports that you may have gotten secondhand. Say you start a new job and you have a ton of reports that you have to clean up and you're not sure where to start. You don't know which measures are needed or which fields are needed. Measure Killer is a great, mostly free tool that you can do a lot with. And that is all I have. I'll go ahead and stop sharing my screen. And Kristyna, over to you.
Awesome. Well, thank you, Lenore. This is amazing. I'm super excited to see what you guys have going on. Let me go ahead and share my screen. So for those of you who showed up today, thank you so much. It's always great to see familiar names in the chat. I'm always excited to give presentations, even virtually. If you're able to come to in-person events, I cannot recommend it enough. Not only do you get to meet amazing people like Lenora, you also get to meet, other people who could help bolster your career or make a big difference in your data journey as a whole. Are you getting feedback as well, Lenore? Is that just me? Am I just hearing feedback?
I am getting feedback. If everyone can just make sure that they are muted.
Cool.
And yeah, I'm seeing some other folks saying that they're getting feedback too.
Awesome. I'm not hearing it anymore, so thank you to whoever was able
Mission accomplished. Nice.
to get that off. I appreciate it. So with that, I'll dive in. So today we're going to be talking about mastering data quality validation in Fabric for Power BI reports. So if you don't know me, I am Kristyna Ferris. Like Lenora said, I am a Microsoft MVP for Data Platform and Fabric. I'm also a solution architect over at P3 Adaptive. Always love chatting with people about the work we do. Very passionate about the amazing team of people that I get to work with over there. I'm also a co-organizer for the Lexington Data Technology Group. So if you are in the Lexington area, if you're ever in Kentucky, feel free to ping me. I'm always down to grab a coffee, grab a bourbon, whatever you're in the mood for, depending on the time of day. Always happy to meet new people in the data community. I also co-write on Data on Wheels. So that's a blog that my dad actually started back in 2010. So him and I kind of co-write on it. So check that out. I try and blog on there relatively frequently. We were kind of talking about it a little bit ahead of this call, but I don't blog as much as I should. I've been more into speaking and meeting with people in person. So you'll more likely find me at a conference than than catch me writing a blog, but I do enjoy it. So feel free to check that out. Also, if we're not connected on LinkedIn, I love being connected with LinkedIn. I think that's one of the best ways for us to share new ideas or new events that are happening. So please connect with me on LinkedIn if you aren't already. Also, feel free to follow me on Twitter and on Blue Sky. Both of those, I'm data_dragoness. And just stay in touch, right? 99% of what we're doing here is sharing ideas. So definitely down to stay in contact and grow together. All right, so data quality. When we talk about data quality, the key we're trying to build on is building trust, right? So if you're thinking about a report, I don't know about you guys, but typically I'm inheriting reports. And 9 times out of 10, the reason I'm inheriting it is because it's no longer being used in the way it was supposed to be. Or I'm inheriting a report because I asked if a report existed that answered a business question, and they said, yes, kind of. I don't know if any of you have been in that scenario before, but typically what can happen with a Power BI report especially is you end up with multiple sources of truth, and you end up in a scenario where people don't trust the data that they're seeing in a report. So what we're going to talk about today is how we rebuild that trust using things like automated data quality checks. Now, one thing that Fabric has done for us is made this a million times easier. John Kursky has amazing blog series on this. He's got video series on this using data ops. What we're going to talk about today is an even lighter version. So something that you can basically take what I'm going to give you today and run with it, and it'll help you rebuild that trust with your end users. So with that, let's talk about why Python, right? If you are like me, maybe your initial data journey started something like, hey, I'm taking Excel files, I'm putting it into Power BI, I'm visualizing it. Wow, this is so much better than pivot charts. All right, now I'm getting dangerous. Okay, it's time for me to learn some SQL. So maybe you've learned SQL in the past, or maybe you're starting that journey now, and you think to yourself, okay, that should be it. That should be the amount of code that I need to learn to do my job well. I'm going to tell you right now, I was in that camp for a long time. I did not start learning Python or think Python had anything to do with my job description until about a year and a half ago. And I'm here to tell you, Python's pretty powerful. So why Python? We get this unlimited power with things like looping, with things like user-defined functions. Can you do some of that in SQL? Yes. Is it very performant? No. I would argue that SQL has its wide breadth of use cases, but we're going to be talking about a particular case where Python is going to be the tool that we're going to use. And I'm going to show you why, right? Where that power is coming from and why it's worth learning, right? Because let's be honest, nobody wants to learn something. Well, I take that back. I have met many people who want to learn something just to know it. I am not one of those people. I personally have a really hard time learning something unless I have a real live use case for it. So if you're like me and you're trying to figure out how you're going to get into this Python thing because everybody's telling you you need to, what I'm going to give you today is going to give you a use case. And I hope that you take it and run with it. At the end of this, I'm going to give you a GitHub link, and in there is going to be all the files that I used today. So you'll be able to recreate this on your own for free if you ever want to. So with that, let's talk about what you'll need in order to replicate this. So the first thing you're going to need is a Fabric capacity. This can be a trial capacity. I'm actually going to be using a trial capacity today. You can also use an F2. What I used to do is use an F2 and I would hit play on it before I would present, and I'd hit pause afterward. And maybe, you know, I'd run it for a little bit beforehand to do some last minute testing and make sure everything was running. And that maximum cost me $2 a month. I had never had an Azure bill over $5 for having an F2 capacity, and that was able to run what I'm about to show you really easily, really well. So if you're a little bit scared of that, or you're not really sure how much you want to put into that monetarily, number one, use the trial capacity. Number two, if you're not able to use a trial capacity, but you are able to spin up an F2, I highly recommend it. It's not going to take a lot of money or effort to try this out and get a good POC under your belt. So that's the first thing you need is a Fabric capacity. The second thing you need is to add data to a Fabric Lakehouse. I'm going to show you some screenshots of how to do that. When I add data to a Fabric Lakehouse, there are probably 600 ways to do it. I'm going to show you the easy way, the way for this kind of POC. The third thing is we're going to be connecting to data from Fabric in Power BI Desktop. So I'm going to show you how you can get those connection links from a Fabric Lakehouse. Again, there are a few ways to do this, but I want to show you kind of the implications, and multiple ways to do the same thing is never a bad thing. The fourth thing we're going to do is going to be the bulk of our time today. We're going to create a notebook in Fabric to actually run the data quality check. So we're going to actually create a couple of notebooks. I'm kind of lying to you here. We're going to create a couple of notebooks. The first one is going to house a bunch of these user-defined functions, or UDFs. Now, if you have also been following Microsoft's release schedules and maybe you tuned in and watched the FabCon keynote that they released, You might have heard UDF a couple times. There is a UDF coming out for Fabric, user data functions, because they love messing with our acronyms, right? Microsoft loves using the same name for the same thing multiple times. But that's all right, because we can work around that, right? We're smart people. The second one you might have heard of is in DAX. They're coming out with user-defined functions. Those are actually the same thing that we're going to talk about today in Python. So learning the concept of a UDF is going to play a really big role in Power BI development going forward. So I can't recommend enough. What we're going to talk about today is going to have implications for multiple coding languages, not just Python. So yeah, stay tuned for that as well. All right, so with that, what we're going to start off with today is creating a Fabric capacity. So I'm just going to show you a couple screenshots of this because, again, I'm doing this with a Fabric trial. I'm going to show you where you can see if you can start a Fabric trial. By default, Microsoft has enabled this in tenants, but tenants, tenant admins, they can go in and turn it off. So if you don't see the option I'm going to show you, you might need to talk somebody into giving you a trial capacity. I personally, as a tenant admin, I have turned it off before, but there are capabilities for them to turn it on for just certain security groups. So if you are in a power user group or something similar, you might still be able to get this without them turning it on for the whole tenant. If you are trying this on your own, you can create a Fabric capacity inside of Azure Portal. What you will need is one, a subscription. This is basically going to be your credit card information. It's going to contain all the payment details that Microsoft needs to bill you. The second thing you're going to need is a resource group. Typically in larger organizations, the resource group is meant to be kind of a billing category or billing group. When I did this the first time, part of the reason I have this slide in here is I did not know you needed these two things in order to make a Fabric capacity. So if you go into the Azure portal and you just click create capacity, it's going to require you to assign a subscription and a resource group to it. It's not that scary. It feels really scary. It feels like I'm locking myself into some kind of big old contract where I'm like having to sign it in blood, but I promise you're not. We can even maybe do another session on, how to set this up. But at a high level, this is what you would need to make a Fabric capacity. Yes, you will get a copy of the PowerPoint. I see that question in there. The PowerPoint, again, is going to be in the GitHub that I'm going to share with you. So you'll have access to that forever, even well after we chat with today. So, all right. The next step we're going to talk through is just adding data into Fabric. Again, I want to cover this in case you want to build this on your own later. There are quite a few ways to get data into Fabric, and that's by design. There are a lot of different reasons why you might choose one or the other. For a POC, I typically recommend putting it in a CSV file, your data, and uploading it into a lakehouse. It is that easy. It is essentially, if you've ever uploaded data into a SharePoint or into a OneDrive folder, it is really similar to that. You'll essentially get this option of uploading files in the get data, and then you can just convert those into Delta tables. So again, I'll show you that, but just wanted to call out, I have loaded data into Fabric, and we're going to be using that inside a Power BI report. And when we are calling that Power BI report and we're running SQL queries against it, we're going to compare it to SQL queries against this lakehouse. So again, if you are trying to build POCs, I can't recommend this method enough. If you're not, then you know what? Call me. Let's have a chat. Let's figure out what option makes the most sense to get your data into Fabric. All right, so the last thing, and then I promise we're almost on the slides, but the last thing here is we're going to connect to data from Fabric in Power BI. I just want to call out that you do need a SQL connection string, and you are going to need to use the SQL Server database connector inside of Fabric or inside of Power BI to connect to this. There is a box in Power BI, an option for Fabric connectors, and the only thing in there is data flows, which can be really confusing, but I promise you can connect to Lakehouse data from Power BI Desktop. You just need the SQL connection string. So I'm going to show you where to find that. All right, finally, we're all done with slides, guys. If anybody has coffee, now is the time to sip on it because we're going to dive into some live demos. So with that, go ahead and get out of this. All right, so I am in Power BI/Fabric right here. Now, the reason I know that is because you can see we've got this handy dandy little app.powerbi URL. Oh, and I'm making squares when I mean to draw some arrows. Nope, I'm really good at squares today. There we go. So you can see we have app.powerbi. I love it. Margarita, not coffee. Even better. But from here, you can see that I'm in Power BI and I'm able to make Fabric artifacts. Now, the reason I can make Fabric artifacts is because I've got this handy dandy little diamond that says I am in a Fabric content enabled workspace. So if you don't see Fabric content, that means you cannot create Fabric artifacts. You also won't see the ability to create them, right? But if you're curious why you won't have these options I'm going to show you in the new item options, that would be why. I mentioned before, Fabric trial capacity. If you haven't set one up, the easiest way is to click on your little person here, and then underneath license type, it should pop up with an ability for you to sign up for a free trial. Mine doesn't really like to load. I have, let me just grab real quick. As a true Lord of the Rings nerd does, I have created fake users, one of which is Rosie Gamgee, who, if you are not a Lord of the Rings fan, just know that she is the loving wife of Samwise Gamgee, and I also have Samwise. He also has some profiles in here. But you can see here on hers, I have a free trial enabled. And so I have the option here to cancel trial. You would have an option here to start a trial in your user. So just be aware, that's where you're going to see it. You'll have to click on your profile. You might have to wait a little bit for this to load, but then it will load and you're able to start a trial there. All right. So with that, let's go ahead and get into it. So from here, you can see I've made a couple of artifacts. I do have some folder paths in here. That's not going to impact anything that we do today. All of my links are going to be tied to the item IDs. And so we're going to be using a lot of GUIDs here. Yeah, if you have a question, go ahead and put it in the chat and I'll try and answer it as we go along. Otherwise, feel free to raise your hand at the end and I'll leave some time. But all right, so if I hop in here, what I'm going to do is walk you guys through how this is all working together. So like I mentioned, I have loaded data into this lakehouse. Now, personally, I like to prefix all of my artifacts with this kind of LH_NB_. That helps me when I'm looking at my capacity metrics later on. I can easily identify what kind of artifact is taking all of my capacity. It will show up in there that it is a lakehouse or notebook, but why take the extra 3 seconds to figure that out? So that's kind of my naming convention. If you see that pop up, that's what that means. You'll notice the reports don't follow that naming convention because in theory, these would be shown to end users, right? So we don't have to follow that naming convention. We get away with it with Power BI. What I want to show you is that I've loaded data in here. And if I am trying to do this for the first time, what you can do is hit this little get data button and hit upload files. Once you've uploaded the files, they show up down here. And you'll be able to turn them into what's called a delta table. Now, in my preview, it takes a little bit to load. There it goes. But you kind of get that top 1,000 rows. You can see your data that's in here. Now, how would I connect to this from Power BI? That's what I want to show you guys. One way to do that is if you have these tables in a lakehouse, you can click this little gear icon. And then underneath SQL Analytics endpoint, you get to copy this really beautiful string that's really easy to remember. Now, I have issues with how complicated they've made this. So I want to show you one trick. If you are connecting to things in SSMS, you are actually able to alias this. You cannot do it in Power BI, unfortunately, But I did want to show you, if you are constantly running queries against a SQL Analytics endpoint and you're trying to remember what they are, you can do something called registered servers. And so I believe it's under tools, and I should have triple checked this before I started talking about it. It might be under view. Yeah, there it is. Okay, so underneath view, we have this option called registered servers. And what you can do is essentially give it an alias. So if I hit registered servers, this will pop up. I can come underneath here and I have this local server group. If I right click, I can create a new server registration. I can give it a name, like maybe I just want to name it to match what I've already named it. So Lakehouse Hobbiton Data. It's going to be Windows authentication. Actually, it's going to be MFA. Go. So you can provide it with the login that you'll want to provide. Obviously, it's going to have you authenticate each time still. I can say, hey, yeah, I want to trust the certificate. I've got the server name. Actually, you know what? I think I need to give it the ugly name here. Yeah, there we go. And then down underneath registered server name, I can call it Lakehouse Hobbiton Data. Hit save. Oh, I've already made one. If I pop underneath here, you see I have Lakehouse Hobbiton Data. I can now just double click on this. It'll bring me to my MFA login. And then if I go back to SSMS, I can now connect to anything, and it will now have my registered name instead of that really silly, oh gosh, so many boxes. There we go. Instead of that really silly GUID. So I just wanted to give you guys a little tip, a little trick. That's something that when I learned that, it was a game changer for connecting to Fabric artifacts. Now, of course, when you're connecting in Power BI, you will need the full link. So just wanted to give you guys a heads up that if you're also using SSMS like I do all the time, that's one way to make your life a little bit easier. So with that, let's get into what you guys actually came to this session for, right? So we'll hop in. I have a number of artifacts in here. Like I mentioned, I have my Hobbiton Data Lakehouse. I've got a couple of notebooks, and I've got my report. Now, this notebook is going to be the crux of what we're going to talk about today, notebook counting coins. If you go into my GitHub, which I'll share with you guys the link, I will share it at the end as well. But in here, you'll see that we have a couple of artifacts. Counting coins refers to this right here. And so you can see it's got that .ipynb. That is a Python notebook. You can open that in VS Code. You can also open it in Fabric. So let's say that you had downloaded that. I just want to show you how you would upload it. You can do import right here. I can import a notebook from this computer. I'll have to hit upload. And once I do that, if I had these in a download folder, I could easily just upload them into my Fabric environment. So I just wanted to show you guys how you can take what I got and run with it. So I'm going to go ahead and cancel out of there because I already have it. All right, so with that, let's go into our notebook. I have this notebook counting coins, and what I'm doing here is I'm going to be comparing the output of a DAX measure with the output of a SQL query. That's the goal. So the goal is, in this one, we're going to hard code a lot of things that if you were building this in production, what I would do is make them variables, because that is the power of Python. And we're going to see that a little bit today. But I'm going to be walking through each of these step by step and have them build on top of each other. So if you are a Python expert and you're thinking, oh my gosh, she's doing this like totally inefficiently, you are correct. I wanted this to be something that we all understand, right? So this is going to run in different phases and it's going to build on itself. The code at the end of this notebook is what you would want to use. So I'm going to go ahead and scroll down. One thing you'll note that I've done already is I've got this little frozen cell. The frozen cell is in case you don't want to use my UDF notebook. You can use this code block instead. And what this code block is going to do is import a bunch of libraries. One way to think about it is, weirdly enough, it's kind of like importing a bunch of UDFs. So UDFs at a high level, in case you haven't worked with them before, are essentially predetermined blocks of code that you're just plugging variables into, and then it does a bunch of stuff behind the scenes for you. It's really nice because you're not having to rewrite that code a bunch of times. Plus, you can kind of trust people who already wrote the code for you, right? They have tested it. They have a lot of error handling already in there. You don't have to worry about it. So that's one of the main reasons why we're going to be doing this in a different notebook called NB Functions. So pretty neat. We get this option of having a magic command called run NB functions. That's going to call my functions notebook and allow me to pull in anything I've put in there. So in there, I actually have all these libraries, and I'll just show you guys real quick. NB functions. It starts off by doing exactly that import process. So you can see it's grabbing a bunch of libraries for me. I'm going to use some of these inside of my counting coins notebook. I'm also using them in some really fun stuff like my own custom UDFs. Now, why would I share these with you? Because I want you to take from what I've already worked on, right? Take it, improve it, do whatever you need to, but you guys are able to use this code today. Basically, what I've done is it'll give you the absolute file path of a table inside of a lakehouse inside of a workspace. You just need to give it the workspace name, the lakehouse name, and the table name. And you might be wondering, what's the point of that? If you've ever worked with Fabric notebooks before, you might know that you have this option to add data items. I've added in my Lakehouse Hobbiton, but let's say that in another world, in a perfect world, right, this would run against all of my semantic models in my tenant. Those are going to all live in different workspaces. I might have multiple lake houses I have to call. I will not be able to mount or like have access to multiple lake houses at once using this Explorer. That only works, you only get to have one default lake house per notebook. So to get around that, I've given you a way where it will find the exact path for you and you don't have to worry about it. So with that, let's kind of dive in. I'm going to go ahead and start a session. I'm going to go ahead and also get rid of here we go. We're going to clear all our outputs. There we go. Now, the first thing I did, you notice I hit this drop down and I hit start standard session. Concurrency sessions are really powerful. They're really good if you're trying to run multiple notebooks at once in the same session. I don't need to do that today because when I use this run notebook functions, it's going to pull that into my session. If all that's above your head, that's totally fine. Don't worry. You don't need to know any of that to understand what this notebook is doing. But for those of you who might have been wondering why I didn't start that high concurrency, I figured I'd address that. All right, so I'm going to go ahead and run this notebook functions. Again, all this is doing is grabbing some libraries for me so that I can reference them down the road. One way to know what libraries I might be calling is you see this TZ, you see this DT. That means that it's calling those specific libraries that I've called out in my functions notebook. So pretty neat. That's how you can kind of trace why I'm, pulling in certain things. But all right. So right now I'm going to start by setting up some variables. The first variable is my data set. Second one is my workspace. Third one is my lakehouse. That's all pretty standard. The fourth one, you might be wondering, why do you have time zone in there? And you might also be wondering about, this run date time. We're actually going to be using those for some logs that I'm making at the end of this. And so at the end, just so you guys know what we're building toward essentially having a table. And that table is going to have my metric that I'm trying to calculate the quality of, my Power BI measure that I'm referring to, my SQL query that I want to reference that should match my Power BI model, and then the difference between them. And then I'm also going to capture the time that I ran this quality check. The reason I'm doing that is that I would like a report that shows me if my data quality is dipping over time. I'd also like perhaps, a report that I could have emailed to me on a subscription once a day, once a night, whatever. You can have activator set up on it. You get a lot more functionality if you are tracking your data quality. So sometimes it's not enough just to be running data quality checks. Sometimes it's good to track it as well. All right, so with that, I'm going to go ahead and go down. The first thing we need to do in order to build that table is we need to be able to run Power BI DAX measures. Now, if you have ever used the REST APIs, you might know that the Power BI REST APIs require you to get a nasty looking bearer token. If you haven't used them, welcome to the future. You are going to be in a beautiful state of bliss. This is the best thing that's ever happened. It's called the Senpai library. And what it's doing is it's actually taking the user I'm logged in as, and it's getting the token for me, and then making it really easy for me to call these REST APIs. It's pretty clear what's going on here, right? I'm just giving it the data set, I'm giving it a measure, and the workspace that the data set lives in. And what I'm doing is I'm putting that into a data frame. Now, a data frame in Python is going to be essentially a table. It's essentially a way that Python is able to identify a set of data that you can then manipulate later. So that's why it's really important that we put it in something called the data frame. I'm going to go ahead and run this, and we'll be able to see the result of me looking at the measure called cost inside of Hoppiton. Now, if you might be wondering why I went with measure, you can call any DAX query this way, but this one is evaluate measure because at the end of the day, I want to be able to just quickly run my list of measures down the line. Now, pretty cool. It took 16 seconds. Again, you might be like, oh gosh, that feels pretty quick, or you might be like, oh my gosh, that feels like forever. I promise that the best part about this is that we can loop. And so we're going to see that in a bit. But pretty powerful. I've already been able to come up with the cost from my Power BI model and load it in using Python in Fabric, right? So this is pretty exciting. We have half of our equation done, right? We're able to call a DAX measure. That's awesome. The next thing I need to be able to do is call a SQL query against my lakehouse. Now you might see here, I'm directly calling that AW sales. If you cannot do it this way, you'll want to use that path that I shared with you. So I want to show you guys happy path, right? We're going to make this really clear and easy to understand. One thing that I've run into Python is that if you're calling a bunch of stuff and it's all nested, it can be hard to know what's going on. So that's why I've hard coded a bunch of this so that it's really easy to see where I'm getting data from. So to start off with, you'll see it's actually pretty easy to call a SQL query using Python. But what I'm going to be doing is calling something called Spark SQL. Now, T-SQL, SSMS uses T-SQL. It's pretty common. I think that's probably the most common use case of SQL is T-SQL. You might be wondering, I didn't even know it was called T-SQL. SQL is so popular that everybody wants a piece of it, right? So what they've done with these PySpark notebooks is they've given a slightly different language called Spark SQL. Now, Spark SQL is optimized to run in these notebooks. So you might notice, limit 10 is not the same as a top 10. But this entire bottom query is the same as I would write it inside of T-SQL. So if you need to, I will just, I'm not here to advertise for any company, but I will say this, ChatGPT does a really good job of converting T-SQL into Spark SQL and vice versa. So if that's a sticking point that you have in your head, I would definitely recommend using that tool. I've had a lot of success with it. I have had almost no success. This just might be me personally, maybe ChatGPT and I are not as close buddies as I thought we were, but I've had a hard time converting SQL into Python. It's not that great at doing that. This is kind of like converting Spanish to Italian. They're already pretty close. They're already pretty similar in their sentence structuring. And so the translation is much easier and much better. So if you have SQL queries, I recommend going with this path of running a SQL query inside a Python notebook and comparing that to your Power BI. All right, so I'm going to go ahead and display this. We're going to get both of these tables back as data frames. Again, data frames is going to give us a column and rows, basically a table inside of Python. And so this is loading them into what's called Spark data frames. That's why we've got this display function here, is so that we can get that in this kind of format. So it's pretty cool. You can even leave these in notebooks, these displays. I personally love them for when I'm troubleshooting later. I'm really easily able to see what got pulled. I've got built into a lot of my notebooks things like showing me a top 1 record so I can make sure things are loading in as I expect. So I'm going to go ahead and take a peek at this. You can see we've got 2 options here. I've got the first query with that limit 10, and I've got my second query, which is just doing that sum of order quantity. Pretty cool. You can see it respected my rename as order quantity, order quantity. I can even scroll over here. You know, the ever popular export to Excel option is here, except you can't export to Excel. You can export to CSV. And you might be wondering, why did they do that to me? I love Excel. Now I'm going to have to figure out my formatting. The reason they do that is they don't want you to be hung up on some of the Excel limitations. So for example, if I click on this download to CSV, I don't get that fun pop-up about the 150,000 row limitation because it doesn't exist for this. So just be aware, this is also pretty nice if you're trying to run queries and just quickly manipulate them and see what's going on. You are able to easily download from here. All right. James does bring up a good point that you will likely also have access to Fabric Copilot. You can easily do it from there without needing ChatGPT. They've even got options here like Data Wrangler, where you can come in here and see what's going on with your data frames, see what data frames exist. Pretty neat. So lots of functionality that's in here. You can notice my Copilot is off. You cannot use Copilot with trial capacities. You can do that if you have a actual Fabric capacity. You can even have an F2 and be able to use Copilot now. So that just came out as well. All right, so the next step here is the looping that I mentioned, right? You might be thinking, well, I could just do this on my own. It's cool that it's all in one spot, but what's the power of Python? You told me this is unlimited power. What does that actually mean? This is the unlimited power, this loop that we're going to build. So what I'm doing is I'm hard coding it for this example. What I would recommend is that you load this into a table in your lakehouse and have it run over it. Think about the possibilities here, folks, right? If I have a Power app, a Power Automate app, not Power Automate app, gosh, Power app, I could easily have it in there where I can add in the measures that I'm trying to track, as well as the corresponding SQL query. You could even do what I'm doing here and hard code it. You could upload it like I showed you with that CSV file. You got lots of options to essentially create a table that we're going to run over. And for every single metric in there, we're going to call the Power BI measure, and we're going to call corresponding SQL measure, and we're going to compare them. So I'm going to run this so we can see what that looks like. I will call out as well, you might be thinking these are relatively simple, right? What about my really complicated measure that I want to do data quality checks? I would just challenge the perception that you need to do this on your most complicated measure. Think about the building blocks of that measure and what you truly need to account for. Do you need to account for nulls in a table? Do you need to figure out if your row count is the same between 2 source systems? What are you trying to do from that perspective? And that's going to make a big difference as to what you put in your data quality check. So just be aware that you don't necessarily need to go through every single measure in your Power BI report. Think about the ones like cost or quantity or profit margin, things that are building blocks for all your other measures, the things that are kind of your cornerstone, where if those are wrong, the house falls down. So this is kind of my attempt of thinking about some load-bearing walls, so to speak, in my measure. And I've just picked out 3, cost, quantity, ordered, and profit margin. These are pretty simple queries. I've got things like just summing up the total product cost, summing up the order quantity, and then doing a pretty simple subtraction. And again, this is Spark SQL that I'm loading in. So the simpler, the easier it is for me to do the translation, because there's nothing in this that is different between my T-SQL and my actual Spark SQL. So with that, I've got these lined up. I've given them a header here of metric, Power BI measure, and SQL query. The reason I have this metric column is because as I loop through this table, what's going to happen is we're going to end up with kind of a stair step response where it's going to give us one column for the response for the Power BI measure cost, and we're going to get another column for the Power BI measure quantity ordered, and another column for Power BI measure profit margin. And then I'm going to pull them all back and stack them up. But in order to do that kind of squishing back into one column, I'm going to need a column like this metric one that is just the same and can be referenced for both the SQL query and the Power BI measure. So with that, I'm going to scroll down. This is the first powerful measure we're going to see today, the Power BI measure and SQL queries and comparing the two values. So again, if you remember, this table that I've called is called df_checker. So that's kind of our data frame that we're going to be referencing and looping over. So to do that, I've got this little RDD collect statement. Now, again, a lot of this, if you hover over these things, the IntelliSense is incredible, right? We get things like the returns, what's going to happen from it. We also get notes about what it's doing. You'll notice this one says, hey, this method should only be used if the resulting array is expected to be small, as all the data is loaded into memory. If you are wondering about ways to speed this up, feel free to reach out to me on LinkedIn. I'm happy to chat with you about ways to speed this up. For the loop, I typically recommend starting with something like this, with this RDD collect function. It is not the most efficient Python, but it is more efficient than me running these queries every day. So what I tend to think about is, first of all, what can I troubleshoot? No problem, no questions asked. And if I'm building a POC, you want to be able to understand every single line in that POC, and you want to be able to speak to it in a way that makes sense to your stakeholder, whoever you're going to be trying to sell this process to. So we're going to keep it simple. We're going to have this collect from this DF checker. Now, the first thing I'm going to have it do is give me a variable. I'm going to call this variable current measure, and I'm going to have it grab the Power BI measure for that row. So you'll notice my first one should be cost, my second one will be quantity ordered, and my third one will be profit margin. So this loop right now is only going to run 3 times. If you think about it, right, I'm only doing this for one semantic model. If I have a client right now, for example, who has about 3,000 semantic models. If they're looping through all 3,000 semantic models, and I know that they have 6 measures they want to run against each one, that's really quickly going to be 18,000 runs of this that I get to do with one button click. That's pretty powerful. So that's kind of where I'm talking about, is this scales really quickly and really well for something that efficient. And you might be thinking 18,000, that's a big table. Not for Python, right? So when it's talking about, this collective, it should be small. Think about it this way. It's only going to be these 3 columns, and it's going to be 18,000 rows. I could put that in Excel, no problem, right? I would hate to build it. Let's be honest with ourselves. I would hate to type all that out for 18,000 rows, but I do that once and I'm done, right? That's it. If I need to make adjustments, I can, but that is a relatively small table to maintain in order to have something this powerful. And that's a pretty big example. 3,000 data sets is a lot. All right, so with that, we're going to go ahead and we're going to populate another measure or another variable called current metric. Like I mentioned, that's this metric field here, so it's going to be cost for our first one. The next thing I'm going to do is I'm going to execute the current Power BI measure using exactly what we did above, right, in that small chunk, but now it's going to be looped over for every single row in my data frame checker. So I've hard coded this in there just so you can see it, right? I've got my data set, I've got my workspace name. You'll notice that above I gave you some pretty easy variables that you could plug in, right? So what I would recommend is you swap this out, use the variables instead of hard coding. I just don't want there to be any confusion about what something is. So wherever possible, I'm hard coding for this. But from here, what we're doing is we're creating a data frame. So again, this is another table in Python. And this one's going to be called df_Power BI. So I'm creating this data frame with the result of my current measure. Now you might be wondering, okay, well, that's all fine and good. Why does it matter? Why are we going to be showing this? And what did you mean by those stair steps? I'm going to show you in a second. But the key thing to remember here is I don't actually want to overwrite this every time I loop, right? I don't want to just end up with the last measure in my table. I don't want just profit margin. I want all three. So to do that, I've got this one data frame called df underscore Power BI, and I'm going to give it a new column. That's what this with new column renamed means. And I'm going to have it give it the name of the current measure. So you can see I've got this literal function here called current measure, and it's going to grab the current measure name. It's a little crazy. It'll make more sense when you see it, but we're basically going to make 3 individual data frames that are going to join together, and that's why we're going to end up with kind of that stair step. Now we're going to do the exact same thing with SQL. You can see we've got this with column renamed, so we're renaming the current measure with this kind of underscore current metric. So let me go ahead and show you. You'll see that this last step is the most important. I'm joining this back onto df checker. So df checker exists outside the loop, so it's easy for me to add things to it within the loop and not overwrite it. So I'm going to show you what that does, because again, it's way easier to see it than to try and read the code and figure out what's happening. That is part of why I have so many display calls in here, so I want us to actually see what's happening along the way. Lenora, do we have until 7 or until 7:30?
Listen, I'm not kicking you off. This is great. So you take the time that you need. Some people will need to kick off. But
Totally fine.
we did schedule this until 7:30. So like
Okay.
you take your time.
Just wanted to be triple, I really want to respect everybody's time. So I appreciate the heads up. But all right, so from here, I'm going to go ahead and show you guys what I mean. So I've made this data frame. The first one, like I mentioned, is going to call the cost function from Power BI. And you'll see we have a new column here called new measure. And that new measure is cost. And that cost comes from right here. So again, we're grabbing values from our DF checker, and we're going to execute it and get the value back. So we now have the actual Power BI cost associated with that semantic model. If I scroll down, you'll see I have a similar thing for the SQL cost. I've got another one for Power BI quantity ordered, SQL quantity ordered, profit margin. And then at the end here is my final DF checker. So these were the original columns in DF checker: metric, Power BI measure, and SQL query. And then at the end here, you see all my new columns. I've got Power BI cost, SQL cost, so on and so forth. And now maybe you guys can see what I mean by these stairs, right? I kind of hate having all of these in separate columns, because what that means is if I had 20 metrics, I would now have 60 new columns that I have to account for in my report. Talk about a nightmare, right? We're not going to do that. We are going to end up with just 2 new columns. I only want all my Power BI responses here, and I want all my SQL's responses here. So I'm going to take this step and make it a step ladder, right? I want it all together. And that way I'm actually able to calculate the difference in one swoop without having to worry about how many columns I made. I want this thing to be as scalable as possible. So let's scroll down to the most complicated Python in this entire notebook. And you'll notice I have all of these green chunks in here. This hashtag is the same as a dash dash in SQL. It allows you to make notes. And from there, I have put in as many notes as I would have wanted a year and a half ago. I, at one point in my life, inherited a notebook like this and had absolutely no idea what any of this meant. That looks like entire gibberish to me. And if it does to you, you are in good company. We're good friends now. It's official. But you can see here, I've got some notes here about what it's doing. So the first thing it's doing is we're going to be coalescing a number of columns without renaming them. So again, if you're familiar with SQL, it's a pretty similar concept where a coalesce is going to take the first non-null value in a row and then put it as the value. So if we go back up to our stair steps, in this one, what it's going to take is our first null value for Power BI underscore columns would be this 9.72. In the second row, that's going to be this 274,000, so on and so forth. All right, so what we're going to do is we are going to select all the rows and skip our first two columns, right? Because otherwise our coalesce would only return these two. And then we're going to backfill all the nulls. Again, this is super goofy, but along our chosen axis. Our chosen axis in this case is our horizontal one. We don't need to go by column. We're trying to coalesce this way. Again, Python's super powerful, but that just means that there's a lot of things you can do and a lot of things you don't want to do. So what we're going to do is we're going to coalesce all these together and make that really wide steps into a ladder. So from here, the last things I want are my Power BI measure and my Power BI result. So I'm going to go ahead and run this. We're going to do the same thing with SQL. You'll notice I didn't put nearly as many notes down there. It's the exact same process. And then boom, we're going to end up with these two options here where we got our Power BI results and our SQL results together. I believe there's a question from Scott.
Yes, I was just curious. You said that coalesce is equivalent to which SQL statement?
Coalesce is a SQL statement. So
Okay.
the statement we're doing in here is called iloc. I've learned it by reading. So if there's another way to pronounce it, I'm not entirely sure, but I think of it like ilocate. And what we're doing is basically backfilling in Python is going to be the same as our coalesce in SQL. So.
Okay, thank you.
Yeah, no problem. Index location. That sounds correct because we have to give it indexes. So that would make sense. But again, feel free to take this this code and steal my notes on it as well, because these were the results of a lot of Googling on my part. The first time I ran this for myself, it totally failed. I couldn't figure out how to get it without this function. So this really made a big difference in being able to clean this up. So the last thing I want to show you guys, we've got our two result sets. I've got a SQL version and a Power BI version, and I'm going to join them back together. This is going to look pretty familiar. We're going to take the data frame Power BI cleanup. So again, that's kind of that table of Power BI measures that I've got here. And I'm going to join it with the SQL cleanup version. And we're going to join on the column of metric. So that's where I have this, pretty standard cost, quantity ordered, and profit margin. This exists in both of these cleaned up tables. So that's what I'm going to use to join. The Power BI measure column, that cost and then quantity ordered with the space and the capitalization, doesn't exist in the SQL query. And so that's why we need something to join it to, which is why I have kind of that universal metric name there. All right, now one thing I did want to call out here, you'll notice that I have a new column called difference. What else you might have noticed is I put in here round to the 4th digit. I don't know about you guys, but I really would have thought I wouldn't have to round. I thought for sure these results would be exactly the same all the way down to however many decimal places. Unfortunately, they are not. So something I ran into, if I look at the SQL result and I compare it to the Power BI result, you remember cost and quantity ordered. Those two are pretty simple sum SQL responses. Inside of Power BI and SQL, we have a difference when it comes to profit margin, which was the subtraction of two sums. So you see here we have 1255, 128593 versus 299. I have literally gone into this data set row by row, literally row by row, and figured out that these are exactly the same, the Power BI semantic model and the SQL table that it's referencing. I have done a lot of Googling as to why these would possibly be different. And the only thing that I was able to find on the World Wide Web was that the Power BI engine and the SQL engine round at a certain degree differently. Absolutely crazy, absolutely nuts. And it was driving me nuts because then my difference wasn't 0 and I couldn't prove my data quality was as good as I thought. So I'm going to recommend to you to round to the 4th digit. Yeah, I'm sorry, James. It's not a Python issue because I had Power BI and SQL give me a certain degree of accuracy, and it was a nightmare. I don't have an answer for that other than don't round to the 5th degree. You can see that this is actually pretty far in, but what I would recommend is, if you have a use case where it has to be that precise, make sure to call out that there are rounding issues, right? Make sure to explain to business users, hey, I can't guarantee these are going to be the same to this level. I can guarantee this much. I can guarantee to the 10,000th place. I can't to the 100,000th. And most of the time, the 10,000th is okay. So if you absolutely can't have it do that, one way I saw online that people worked around this was multiplying it and pulling it out of the decimal places to the degrees that they needed. So they were able to multiply that profit margin number by a certain amount and get around this rounding issue because it does only happen in the decimals, not in the whole numbers side of this. So if you desperately need a way to do that, that's what I would recommend. But all right, so I'm going to go ahead. Oh gosh, yes, someone found the rounding error. Perfect, Tamil. That was great. But yes, from here, I've gone ahead and just handled a rounding in there. And the last step here is going to be writing into a delta table. So again, when I say writing, I'm going to append into this table a few of these records. So you might notice I've gone ahead and added a couple more columns in here. I've got the run date time, I've got the semantic model, and the workspace. These are pulling from those variables. Again, normally I'm hard coding this, but I figured for this one, I can just go ahead and use the variables we called out at the beginning. What I'm doing is I'm creating a few columns at once. So each of these with columns creates a column in a data frame. So I've got a with column. This is going to be the name of it. You see that run date time corresponds here. And then I've got this lit function, and it's calling my variable run date time. Now this run date time, we calculated all the way up here. Go way far back. You can see I've got this v run date time. This variable was calculated when we first executed the notebook. If you want to change that, you can rerun that variable closer to this actual call so that it's closer to the time that it actually got run. But I've gone ahead and just put all my variables in one spot so that it's easy to find things later. You'll notice that I also have another new column called semantic model, and this is going to give me my variable data set response. Now, if you are new to Power BI, you might be like, why are people calling semantic models data sets? I would just give you a little brief history lesson. Power BI has gone through a few naming changes, like every Microsoft product has. Semantic models used to be called data sets. If you are running old APIs, they all say data set. They mean the semantic model. It is the same. Another fun thing, fun fact that not many people know, is workspaces used to be called groups. So when you see groups in the URL in Power BI, this GUID is actually your workspace ID. So you can get it from anywhere inside of Fabric. You just need to know where to look inside the URL. All right, so with that, I've gone ahead and added these new columns. I've written it to this data quality delta table. The last thing I'm doing is a little controversial, I won't lie. I am going to be syncing my Lakehouse endpoint to the Lakehouse. If you are relatively new to Fabric, something that you need to be aware of is that the SQL endpoint, that query, that string that we grabbed at the beginning to use inside Power BI, is not the same as the Lakehouse files itself. Those Lakehouse files get converted into something that SQL can call, and That's the SQL Analytics endpoint. Now, they are getting better at this, but there's still no guarantee as to when the SQL endpoint will have the new information you've loaded into your lakehouse. What do I mean by that? Sometimes it is really instant, and sometimes it takes 2 hours. I have only seen the 2-hour thing happen like 3 or 4 times, but it was enough for me to panic and try and figure out how I could force those things to sync up. And so I've made a user-defined function for you. It's in that notebook functions. And what it does is you can give it a workspace name and a lakehouse name, and it will force the sync for you. It will say, hey, I have new stuff in the lakehouse SQL endpoint. I need you to look at that and make sure that you have it. This is not supported by Microsoft. I do need to throw that out there. What does that mean? It means that if this does not work for some reason, Microsoft will not help you with fixing this problem. So just want to call that out. I have had 0 issues running it, which is why I'm comfortable sharing it in a public setting. But you can see here we get fun things like, hey, you know, the table sync status was not run. You can see the last update was none. Some of these are not the best responses. I won't lie to you. It's whatever I could pull out of the API response. So what this is doing behind the scenes is calling a REST API. And so this is the table that I just updated, and you'll see it has last update none, but you can see my table sync state was success. So I'm good there. The other ones, the table sync state is not run. The reason for that is because nothing was updated in them. So I wouldn't expect anything to happen there. What I'm really looking for is just that this says success. So we're good there. I'm confident that if I had a Power BI refresh after this, it would grab the correct data. It's not going to grab an old version of the lakehouse that the SQL Analytics endpoint has. So, all right. So with that, what does that table actually look like? Let's go in here. You can see we have our data quality log. Oh, it did load. Okay. Real quick, I'm going to back up a little bit to the beginning when I was telling you how I made these Delta tables. I uploaded with this get data, uploaded some CSV files. You can still see those CSV files here in the lakehouse because lakehouses can hold CSV files. And then I just hit this little 3 dots and then loaded to a table. That's how easy it is to convert these into lakehouse tables for you to use in Power BI. So again, if you're building something on your own, feel free to do this. Anyway, back to my data quality log. You can see here, we now have our latest and greatest runtime, and I can see at a glance these 3 records got created today, and there was no difference between my Power BI measure and my SQL query, and that's exactly what I want to see. When I was first building this, I purposely put in some errors, and you can see that my difference was actually 7 or 8. You can see the logs and understand that my data quality has remained consistent since a certain point in time. That is a really powerful tool to be able to show business users. And I showed you how to compare a Power BI semantic model with a SQL query. You can do this between 2 semantic models really easily. You can swap the chunks of code that I had that were calling SQL queries and have it just call another set of DAX queries. And that can be how you make sure your finance numbers are going to match what the executive suite sees. Little things like this are going to save you a lot of headache and a lot of trouble with figuring out exactly where your data quality is lacking. So, alrighty, folks, with all of that, are there any additional questions? We're at the end of my notebook.
So James did put a question in the Q&A. And James, feel free to come off mute if you'd like. And if not, I'll just read it. 3, 2, 1. So he said, I'm curious about the pros and cons of this approach versus semantic link, the execute queries, REST API endpoint, etc.
That is a great question. So one thing I have run into with the semantic link, and what James is referring to, is you see I have this SymPy fabric. SymPy fabric is a library that's easy to call. Semantic link, you have to pip install it pretty much every time you run a notebook. Now you might be wondering, well, that's not a big deal. This is just one line of code. The reason I'm not using the semantic link in this notebook is because if I ever want to run run multiple, you can't do that with a pip install. So the pip install actually can't live in my notebook functions. It would have to live in this notebook. I don't love that. I feel like that's a really janky problem to run into. That's going to change soon with the libraries that they're coming out with, hopefully. But typically, I would not use anything that requires a pip install in a scenario where I might want to run multiple notebooks at once. So yeah, I think John had you set up an environment that, yes, that is how you would have to do it, is setting up an environment that already has the semantic link installed. For the purposes of this, just because, I'll be honest, just because we're all learning Python, I didn't want to have you guys also create an environment. So this gets around that issue that I've run into with semantic link labs. Also, I don't find that the semantic link labs are necessarily faster or easier than SemPy for these calls. Semantic link labs is really good at a lot of things, but I don't find it necessarily better than using the SemPy library. So yeah, John, we'll have to have another video, maybe by you, on how to set up an environment. But yeah.
Yeah, just a heads up, anyone who's talking more than 2 or 3 times in the chat is going to be harassed into giving a talk themselves. So you're leading me well ahead. No, this is great. Another question from Steph.
Yeah, did you notice a difference in the speed of the checks depending on the different sizes of semantic models? If one model has a lot of measures versus another has less, did the checker perform differently? The big difference that I've run into, as far as size of semantic models, it doesn't really matter how many measures are in there. It matters how many you're checking. So the process that I've shown you, this loop process, is going to go through each measure individually. There are ways with Python. They are more complicated, which is why they're not part of this session. But I'm happy to share with you outside this session to essentially run multi-threading is what it's called. And it can run multiple at once. So in that way, that is another way for you to speed it up, especially if you have a lot of measures you need to check. I would recommend doing that. As far as the different sizes of semantic models, if the queries you're calling are relatively simple, so again, if we keep this to things like the cornerstones, we're talking like, sum of costs, sum of sales, count of non-null fields, count of rows, and we're just trying to compare that, it's going to run really quickly. If you're talking about, I need to check for a specific row-level security instance, what they see versus what they would see in SQL, you're going to get a much more complicated query and it will take time. It's only as fast as the semantic model would return something as far as giving you the result from Power BI. It is executing against that semantic model, and so it does rely on how fast that is. If you have a semantic model that you're trying to call a DAX query for, and that DAX query takes, an ungodly amount of time, this will be slower. The benefit to having it in here, though, is hopefully you're not sitting there looking at it. Hopefully you're running this overnight, or you're running it at the end of an ETL process, something similar where you can be able to tell. So that's what I would recommend there. That's part of why I call out you'll want to use your cornerstone metrics for that instead of more complicated measures. Good question, though.
Fantastic. Other questions from the group? Okay.
I'm going to put in the chat one more time the GitHub link. So again, this is going to have that PowerPoint that I used, and then those 2 notebooks, as well as the actual Power BI model, in case you're curious what that looked like. But yeah, let me go ahead and throw this up if there are no more questions.
We have just one more from Andrew, who said, have you thought about integrating with a Python testing framework, but like Great Expectations?
I have heard, I've gotten that feedback a few times now.
Interesting.
And I have not, but I need to.
Hmm.
That is it is now something I officially need to look into. So I appreciate that feedback, Andrew, and I will be looking into it.
Fantastic. Well, this was amazing. Thank you so much, Kristyna. I really, really appreciate all of your insights.
Yeah.
To
Thanks
answer
for
some of
having
the,
me.
oh gosh, this is great. To answer some of the folks in the chat, yes, we will be posting this on the YouTube. Please be patient because we are not always great at learning how to make the YouTube work the way we intend it to. So sometimes it takes us longer than we anticipate, but we will share that as soon as we can. And in the interim, if we struggle, please be sure to explore the wonderful write-ups that Kristyna has provided us with. But yeah, I hope to see many of you next month. And Kristyna, my fingers are crossed that we can tempt you to come to Power BI Days this year.
Oh, girl, it is it's already tempting. So
Oh,
the
okay.
real trick is that is also my husband's birthday, and so
classic.
we
A
might
classic challenge.
be somewhere else in the country for that day. But
Well, we will forgive you just this month once, but I will note DC is a wonderful place to go out to dinner. We have wonderful restaurants.
you
And
know what? We'll have to connect on some golf courses for him.
we'll
Maybe
talk.
that would
We'll
get
talk.
him. Yeah.
Oh yeah, you've got options. All right. Thank you all, and I look forward to talking to many of you next month.